Alright, for the directions for number 8, tell us to find the velocity and the acceleration at time t for the functions, so our general functions for each. Then describe the motion of the point during the indicated time interval using a diagram. I'm going to add one more thing in here that I want you guys to do. We'll do together for this one, is find out when it's speeding up. So when is it speeding up? So let's first find velocity and acceleration. Remember, velocity is just the derivative of position. So we get 2t plus 3. And then acceleration is going to be the derivative of velocity. So in this case, it's just going to be 2. That's it. It's always going to be the same. Now, in order to sketch a diagram, we need to look at a few different points. We need to look at the critical values and the endpoints. So we need to figure out when is this velocity equal to 0. So t equals -3/2 is a critical value of the position. That's when the derivative is 0. So we have to figure out what's s of -2, s of -3/2, and s of +2. So we're taking each of those x values and plugging it into the original. So when we plug -2 into the original function, we're going to get -2 in parentheses squared plus 3 times -2 minus 6. And that comes out to be -8. If we put -3/2 back into the original function, we end up with -8.25. And if we put 2 back into the original, we end up with a position of 4. So we're going to sketch a diagram on the number line, really above the number line, for the position from t equals -2 to t equals 2. So our points we've got here, I'm going to plot 0, 4, and -8. And plot our points. So we start off at -8, then we go to -8.25, so just a little bit to the left, and then all the way to 4. So we're starting here, going to the left, and then going back to 4. And we want to label the times that each of these happen. So t equals -2 is our starting time. T equals -3/2 is when we change directions. And t equals 2 is our endpoint. So now the last part we have is answering the little supplemental question that I added on at the end. We want to figure out when is this speeding up. So we need to actually do a number line for the velocity and for acceleration. So I'm going to do the velocity on top. And we figured out already that the velocity is 0 when t equals -3/2. So I'm going to have -3/2 on my number line. And velocity, if we look at a number to the left of that, like -2, if we put -2, in here to our velocity equation for t, then we're going to end up getting a negative number out. If we put 0 in for t, we're going to get a positive number out. So all the velocities are going to be positive to the right of -3/2, negative to the left. And this one's a little bit different because for our acceleration we're going to put down on the bottom. Normally we'd put a point or two where the acceleration is 0, but in this case acceleration is always 2. It's always going to be positive. So to find when it's speeding up, remember that's when either acceleration and velocity are both positive or they're both negative. So the object's going to be speeding up from -3/2 to infinity. because both velocity and acceleration are positive. They're moving in the same direction.